Hello all. So in the last few sessions we were discussing about best practices in developing NLP application, where we have discussed various topics on batching, that is sorting, padding, masking, and then we have seen how do we avoid overfitting, and then we have seen how do we balance, uh, how do we deal with imbalanced data sets, and so on. So today in this session I would like to talk about another important practice that we usually uh, use when we try to develop NLP application, which is hyperparameter tuning. Okay. So today we will discuss about what hyperparameter tuning is all about and how does that help. Hyperparameters are basically the parameters about the model and the training algorithm. Once we develop an algorithm, we fine tune the algorithm parameters such that will help us in developing good model. So this term is used in contrast with parameters, which are numbers that are used by the model to make predictions from the input. Okay, so that is the reason we have been calling this as magic constant throughout. Okay, so they work like constants in programming languages, although their exact values are automatically adjusted by optimization so that the prediction matches the desired output as closely as possible. Okay, so correctly tuning hyperparameters is very critical for any machine learning models to work properly and achieve great potential. And for this reason ML practitioners actually, you know, spend a lot of time tuning the hyperparameters. Knowing how to tune hyperparameters effectively has a huge impact on the productivity in building many machine learning or NLP systems. Okay, so when we talk about examples of hyperparameters, okay, so hyperparameters are meta level parameters. Unlike model parameters, they are used not to make predictions but for controlling the structure of the model and how the model is trained. For example, if you're working on word embeddings, okay, or an RNN, how many hidden units are there for using, how many hidden units to use for representing words is one important hyperparameter. Okay, in the context of word embeddings. Okay, now the number of RNN layers used is another important hyperparameter. In addition to these hyperparameters, that is the number of hidden units and layers, the transformer model, when we talk about the transformer model, such as number of attention heads, okay, and the dimension of the feed forward neural network, okay, each, even the type of architecture we use, such as RNN versus transformer, can be thought as one of the hyperparameters. Okay. Besides the optimization algorithms, you may have to use hyperparameters. For example, like, you know, we will learn about learning rate, which is one of the most important hyperparameter in many ML settings. Okay. It determines how much to tweak the model parameters for optimization steps. Okay. Apart from this, the number of epochs, okay, the iterations to the training data set is also an important hyperparameter too. Okay, so far we have been paying very little attention to these hyperparameters, let alone optimizing them, right? However, these hyperparameters can have a huge impact on the performance of machine learning models. In fact, you know, many ML models have a sweet spot of hyperparameters that make them most effective, whereas using set of hyperparameters out of this spot may, make the model perform poorly. Okay, so for this reason, most of the ML practitioners tune hyperparameters by hand. This means that you have to start form a set of hyperparameters that look reasonable and measure the model performance based on the validation set that we were discussing in the last class. Okay, so then you can change one or more hyperparameters slightly and measure the performance again. You can repeat this process several times until you get the good result. Okay, so one issue with manual tuning approach is that this is slow and arbitrary. Let's say you start from one of set of hyperparameters, then how do you know which one to adjust next and how much to do, where do you stop and all that. So instead of all this, we go for certain hyperparameters tuning in, which will actually help us in improving the performance. Okay, so to talk about them, we talk about, to understand the manual optimization of hyperparameters is inefficient. Okay, but how should we go about optimizing them then? Okay, so we have two more organized ways of tuning hyperparameters. One is called as grid search and the second one is called as random search. Okay, so when I talk about, as you can see here in the figure, when I talk about grid search, you simply try every possible combination of the hyperparameter values you want to optimize. For example, let's assume your model just has two hyperparameters, the number of RNN layers and the embedding dimension. Let's choose, okay, the number of RNN layers and the embedding dimension. Okay, so we first define reasonable ranges for these two hyperparameters. For example, set of 1 2 3 for number of layers and set of 128, 256 and 512 for the dimensionality. Okay, so then this grid search that I'm talking about measures the model's validation performance for every combination. Okay, if I talk about 123 and 128, 256 and 512, one with 128, one with 256, one with 512 and so on. Okay, so this simply picks the best performing combination. If you plot these combinations on a 2D plot, it looks like a grid search, as you can see here in the first figure. Okay, so grid search is simple and best method to optimize hyperparameters. However, if you have many parameters and many ranges, if the ranges are large, this method will go out of hand. Okay, so the number of possible combination is exponential, which makes it impossible to explore all of them in a reasonable amount of time. So other alternative that we choose to grid search is random search, as you can see here in the figure. In random search, instead of trying every possible combination of hyperparameter values, we randomly sample the values and measure the model performance on a simplified number of combinations, which are basically called as trials. Okay, for example, in the previous example, in the random search, we were taking all combinations, right? So unlike that, as you can see in the second figure, this particular hyperparameter search space is very small. Okay, so the random search is usually recommended over grid search if you want to optimize hyperparameters efficiently. Why? Because in machine learning settings, not every hyperparameter is made equal, right? All of us know about this. There are usually only a small number of hyperparameters that actually matter for the performance, whereas others may not. Okay, so grid search will waste a lot of computation searching for the best combination of hyperparameters that does not really matter. Okay, so while being unable to explore the few hyperparameters that do not matter in detail, whereas this random search can explore many possible points on the axis that matters for the performance. Okay, so for that reason we actually go for random search for hyperparameter tuning. Okay, next. Okay, so we have covered how to tune hyperparameters including manual, grid and random search, right? Now, how should we go about implementing it in practice? Okay, you can always write your own for loops in case of grid search, although it would quickly get tiring if you need to write the entire code and the task to go on. Hyperparameter optimization is a universal topic that many ML researchers and engineers have been working. They've been working on better algorithms and many different libraries. Okay, for example, we have Allen. When you talk about Allen NLP library, we have Allen Tune. Okay, so you can directly use that particular Allen Tune for tuning hyperparameters. Okay, so I would like to introduce another important hyperparameter tuning when you talk about NLP applications, which is Optina. Okay, so you can Optina implements the state-of-art algorithms that search for optimal hyperparameters efficiently and provides integration with wide range of machine learning frameworks, including NLP tasks for delivering NLP tasks, which also includes TensorFlow, PyTorch, and all that. So first, we assume we have installed NLP. Along with that, you can also go for installing Optina plugin for LNLP. You can just go for pip install LNLP, pip install LNLP along with Optima, and then you can directly go for working. Not just LNLP, you also have Optima working with Stanford sentiment tree bank. Okay, so Optima work with many of the existing libraries where you can go for hyperparameter tuning directly with respect to one or two lines of the code. Okay, so when I want to conclude the summary of how do we get better performance of the NLP models, we have seen we go for instances, we sort them, we pad them, we mask them, we batch together for more efficient computation, we go for tokenization of the neural models, we use algorithms such as BPE, okay, byte pair Encoding, we split words into smaller units. We don't go for character and word, but we go for subword tokenization, where we employ algorithms like BPE. Okay, and then we use regularization techniques such as L2 dropout. Okay, so to increase the model simplicity and generalizability in machine learning, we also use sampling techniques like upsampling, downsampling, or class weights for addressing the data imbalance issue, for balancing the data sets. And we also hypertune the parameters using different methods: manual search, grid search, or random search. And all these methods actually helps us in developing more efficient NLP algorithms. Thank you.